Let me start recording this. Good. I believe that everybody can be able to import NumPy. I think you can just confirm that by showing me thumbs. You can just raise. You can just do thumbs up. Are you guys able to import NumPy? Because I think that is the first step that we checked. Thumbs up if you are able to do that. Yeah, you can see Joseph. Caroline, are you able to use NumPy to import NumPy? I can see Carl. I can see a number of us are able to do that. Maybe we can just go through it very fast. So we said that for us who are using Colab, you don't have to install that because it is already pre-installed. But in case you're using other IDEs, you can use the pip install numpy. Uh, you can use the pip install numpy. So we say that the first step to use numpy is to import it, and we import it as numpy. We import numpy as np. So np is its alias. So the import numpy is np, and we said that numpy will help us to create what we called nd arrays. So, and we said how you can create an nd arrays is by having your variable as array is equals to, then np, you invoke the function that is called array function, and then you just pass your array of elements. So from that also we checked how you can create how you can create the dimensions in array. We started with a dimension one dimensional arrays, and we said that one dimensional arrays are scalar values, whereby we just have just one value, like in I mean the 0D arrays. We started with zero dimensional arrays where we said that in zero dimensional arrays they are scalar values, such as 42. So, and we said you can create an ND object, and the ND object here is 42. So we can do that by using np.array, and then we just pass the scalar value. So with that, you should be able to get an NDR. I think we checked that. So we also checked the one dimensional array, whereby we say that an array that has 0D arrays as its elements is called a unidimensional array or 1D array. So meaning that we can have a list of scalar values forming the 1D array. And even we saw one example, or you can create. I think Campos gave us an example of one dimensional array. We also check the two-dimensional array, an array that has 1D elements as its element is called a two-dimensional array. So meaning that you can have now a couple of one-dimensional arrays forming the elements of the two-dimensional array. We also had an example, this one. I think I can just run this so that you can see how we go about it. So let me just uncomment this. So we said the first step is import number as np. Then this is an array. I think I can just call it array is equals to np.array. You notice that this one is a function. This one is a function because it has the parentheses. Then you notice here that I'm using two square brackets. That is the square bracket that encloses all the elements in this two-dimensional array. And now the square bracket that holds each element in two-dimensional array. So we have two. So, and then after that, we can just try to print our, the ND, the two-dimensional ND array. So I think you can just run that and see the output. Yeah, and you can see that we already have these. So the same applies with the three-dimensional array, where we said that a three-dimensional array is an array that has 2D arrays as its elements. And I think you can see that I have given an example here, whereby I'm having two elements in these 3D arrays. Maybe let me just try to go through this together, because I know at some point people get confused here. So let me just try to run through this. So we say the first step is always to import the NumPy, and then we have our array here. I think we can just call it array, and then is equals to np array, np.array, and then our function now. And then you notice here that I have how many elements do I have here? Maybe someone can just tell us how many elements do we have here in this three-dimensional array. I think I should. Okay, how many elements do I have here in these 3D arrays? Can someone tell us? Charlotte? Yes, I have Amos Sumbi saying 12. Who else is willing to guess? Mombi saying 2. Who else? Charlotte saying 2. Amos, can you tell us how you arrived at 12?
I just okay. Hello. Okay,
Hello, hello, I can hear you. Yeah.
I just counted the first array as 3.
Yeah.
Then the second. Okay, they are in 333, and there are 4 of them. So basically, like totaling to 12. That's how I counted
Totaling
them.
to 12. Yeah, okay, yeah. Charlotte, can you tell us how you arrived at 2? Or Mombi, either Charlotte or Mombi, because you have same answer. Mombi, how did you arrive at 2?
To the elements inside the array.
Sorry, Mombi, I can't hear you. You can just unmute your mic and or just type in the in-call message. I think I'm able to read through that. So Mombi is saying that the elements inside the 2D arrays. Yeah, 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 yeah. So Amos here, we are saying that, and also the rest, we are saying that a 3D array has 2D arrays as its elements, right? That is what Mombi is trying to tell us, that he counted the number of 2D arrays in these 3D arrays. Because from here, let me just try to highlight these. This one is 2D arrays, right? up to this point, and then we have another one from this point up to this point. So meaning that we have two we have two D. How do I write this? We have 2D elements. I think this makes sense. 2D elements inside the 3D array. I think this makes sense now. Amos, because you can confirm that you get it. Yeah. So that is it. And then you can just do the print. So you shouldn't get confused. Even now, or let's say maybe you want to have a 4D arrays. It means that you are going to have now you are going to have these 3D this 3D array as the elements of the 4D arrays. So I think that is exactly that. I think I'm clear on that. So thumbs up before we move to the next thing. If you have understood that, I can see most of us are okay, because in fact this one forms the basic the base for what we are going to be covering for the rest of this lecture. So I think we are good up to that point. So after now creating after creating these arrays, you might, or maybe you might be required to iterate through them, or go through each element in those arrays, either one dimensional array or two dimensional or three dimensional or any or x. Let me just use x dimensional array. So there is what we call now array iterating. So and iterating just means going through element one by one. So and we are saying that as we deal with a multi-dimensional array in NumPy, we can do this using a basic for loop. I think by now most of us, if not all, we are familiar with for loops in Python. And we are saying that to iterate a 1D array, to go through each element one by one, we just have to use we just have to use one for loop. And I think I can just show you that. Let me just demonstrate that. I think you can have iterating 1D array. It should be 1D array. So the first step is always to import. We already have it. Importing NumPy as NP, and then we define our array here, the ND object, this one. So you can first maybe print. Let me just stop using the for loop and print this. So if we print these, you notice that we are getting a list of elements here. But during analysis, you might be required to go through each element by, I mean, element by element in this, and that is why now we are using the for loop. That is why we are introducing the for loop here. So we just have to say, I think now you know how we use the for loop. That is for x. This one is just a variable to hold any value in this in our array here, and then we print the x. So meaning that if we run these, we should be able to access each element each element. That is 1, 2, 3. Instead of printing the list. So that is basically how we loop through a one-dimensional array. That is one-dimensional array. So we can just proceed to looping through two-dimensional array because it's quite it's different. It's different with the one-dimensional array. And if we can just read through these, iterating through two-dimensional array. So, and we are saying that into the array, it will go through all the rows, just all the rows. So meaning that if we just happen to, okay, let me just show you this. I think this one now becomes interesting. Let me just copy this here. And I can just uncomment this. So this one is a 2-dimensional array or 2D array. So what happens now if we use just the for loop? I think I can just copy this in a different cell so that we are able to run it on its own. So let's check this. Let's print that. Let's run this. And now you notice that we are not able to loop through each element, but instead we are looping through each row because this one is a row. In fact, if we just try to print this, let me show you this. Let's just try to print this array here, and I run this. I think I can just comment the for loop so that you can see this. So you notice that if I print this array R here or array, we are getting two rows of data. That is 1, 2, 3 as the first row, and the 4, 5, 6 as the second row. So, and now it happens that when I just use one for loop here, we are now looping through. I think you can just comment on this. If I run this, we have just like been we have just looped through these rows, just the first row and the second row. So now what is the solution of this? Because our target is to loop through each element here, not loop through the rows. So let's see what we are supposed to how we are supposed to go about it. Let's see that. And we are saying that to return the actual values, that is now the scalars, we have to iterate the array in each dimension. So meaning that for us to iterate on each scalar element on the 2D array, we are going to use two for loops. And these is what we call this for the second loop, we call it the nested. This one in fact it's called the nested for loop, simply because now it is a for loop inside the for loop. So we are going to have for x in the array here, and then we are going to have now for y in x, for us now to be able like to print all the elements. I think you can just try that and see how it works. So now inside this, for us now to print each element here, we are going to have another for loop here. So we can use for y or any other variable that you feel like using. And then let's try now print let's print y. So if we run through these, you notice that now we're able to read through each element in these 2D in these two D arrays? I don't know if there is any question on that. So if you have question, you can just raise up a hand and ask. But this is how now we look through or iterate through 2D arrays. Any question? Thumbs up if you're together. What about the rest? Caroline, are we together? Grace? Grace, are we together? Yeah, I can see also Grace is saying that we are together. So that is basically how we look through 2D arrays. So now that you know how to loop through 2D arrays, who can tell us how we can loop through 3D arrays? You know how to guess that? Because that is the next thing, iterating through three-dimensional array. Now this one is a 3D array. I think you can just copy from these. But I think there is a point where, oh yeah, I think you can, let's use this. I think you can just copy that and bring it here. So how can we loop through this? Who's having a solution to this? You don't have to be right. I think you can just guess, and then we are going to correct you. Any person with an idea of how you can loop through this? David?
I think
Yeah.
it is what the auto complete was just saying. For
Yeah.
X in array, for
Okay.
Y in X, and then for
Let's do that together.
okay,
Yeah. That is for
X in array.
X. Oops. I don't know. I don't know how to switch off these auto. I think we have. Is there a way we can switch these auto complete stuff? For X in for X in array.
Uh, in array, and then for Y in X.
Let's do this. That is now you can see. In fact, this one is doing the whole autocomplete here. I think this now thing is okay for X in array. I'm sure if I write that, it might autocomplete. That is for X in array.
Yeah, for Y in X, and then for Z in
That
Y.
is for Y in X. Then now
Z in Y.
for Z in Y. And then we print
Z.
Z, right? Good. So I think we have it right. So you notice now here we have four nested. I mean four nested loops. Or two, yeah, I think two nested for loops. So if we just happen to run through this, we should be able to get that is each element in this. So I don't know if there is someone who is left behind who doesn't know what we are doing. You can just raise up your hand but only you don't know what the 4y, the x, z, then printing z. Rodavan Mosembi. Any question? Is it a question, Mosembi?
Yeah. Can you hear me?
Yes, I can hear you.
Okay, so my question is on
Yeah.
I have completely understood on the how to iterate. So
Sorry?
my question comes in.
Can
I
you,
have
Mosembi, can you try and raise your voice a little bit?
okay. Just give me a minute. I take up on my mic and then get back.
Okay. So I think this is it. With looping through. That is looping through. You notice that anytime we increase the number of the XDRs, we add a for loop. You notice that for 3D arrays we are having two for nested, two nested for loops. Of course, now for the four, yeah, yes, Rodovan.
Yeah. So can you hear me at the moment? Can you
Yes,
hear me?
yes, I can.
So my question comes in here on these brackets. So how do you like these are three and the other ones are like for the 2D they are two,
Yeah.
like the brackets here on the inserting of the brackets. So how do you go around that?
I think basically we can start from the 1D array. And the 1D array, you notice that we said that a one-dimensional array is formed by having a number of scalar values, or a number of 0D arrays. And in 0D arrays, we said that we have scalar values. So for 1D array, you notice that we have all our values are enclosed in just one square bracket, right? That is 1, 2, 3. Are you together up to that point, Radovan?
Yeah.
So now when we go to the 2D array, now we are going to have our elements. You know, we said that in 2D arrays, 1D array, 1D arrays, what am I saying? We're saying that in 2D arrays, we have 1D arrays is its elements, right? So meaning that we are going to have a number of these one-dimensional arrays as our elements here. And you can see we have this one, and we have another one here, 2. And because they are elements now, we are enclosing them in a square bracket, right? So meaning now we have two one-dimensional arrays here as our elements, right? So when we go now to three-dimensional array, we said that in the two-dimensional array, in the three-dimensional arrays, we have 2D arrays as our elements, right? So all of these, now from here up to this point, let me show you. From here up to here is a 2D, it's a 2D array, right? And now we are saying that in the 3D arrays, we are going to have these as our elements. So meaning that we are going to have a couple of these 2D arrays enclosed in a square bracket. And that is what we have here. Like we have the first element starting from here up to this point. You notice that this one now is a 2D array, and now this one is the second element up to this point. And because now they are elements of 3D arrays, we are enclosing them with this bracket here. Are we together, Radovan, or you are confused?
Perfect. I've got it right.
Yeah. I think that is it with creating the dimensional arrays, and even how to loop through each element in dimensional arrays. So I think that is it. I don't think it's that difficult for you guys to understand that. So what else should we check? I think that one was on iterating items in an array. In an array, I think we have checked all of them. So what now we can go through? You notice that with iterating here, let's say maybe you have a five dimensional arrays. Does it mean you're going to like like write all these for loops for you to iterate items in the 5 dimensional arrays? At some point, you might get that, right? So now Python, or what we call the Numpy, is giving you a shortcut to do that. And that shortcut is something we call the ND iter. The iter is just the shorthand for iteration. So the ND iter, it's a function. This one is a function. Now with this one, we are going like to, it's going to help us to loop through through these without the hassle of writing the for loops. It's just very easy. We are going to see how we can use it, and that is why we are saying that the function NDITA is a helping function that can be used from very basic to very advanced iterations. So that is from 0D. I don't think we need to iterate 0-dimensional arrays, but starting from the 1-dimensional array, moving to n minus 1-dimensional arrays. So yeah, I think that is it. So let's jump into how we can use the ND iter to iterate through these complex arrays. I think we can just copy this example, and just below these, how is that? Yeah, I think we can have it. If you can just add a cell here, and say that we are trying to iterate using ND iter function. So let's see this. So the first step we said is to import this. That is Numpy as NP. Then we have, okay, in this case we have 2-dimensional array. In fact, this one is a 3-dimensional array, because we have, yeah, this one we have 2D dimensional arrays as our elements here. So for you now to loop through this, instead of writing all the for loops, we are just going to write one for loop that will iterate the items in this, instead of having 3 for loops. So we are going to have for x in, we must invoke now np this numpy, because it has this function that is called the nd iter, and then now we are going to pass in our array here, that is this, and then we just print x. It's just that simple. If you just happen to run these, you notice that now we're able to loop through all these elements without the hassle of writing 3 for loops. I think you can just try with this. Let me show you this. Yeah, I think we can try that here. So let me just try to do what, to comment out that, and then we say that for we can have for x in, that is np dot, you can just, we have the autocomplete already. So you notice that we are saying that for x in the np dot nd iter, and then we just pass in our array, and then we just print, we print x. So if we run this, we should again be able to get the same output as using the four loops. I think nd iter got us. We don't have to write all these for loops. So any question about the nd iter? Really, that is the simplest way you can use. The simplest way you can use to iterate through those arrays. So what else should we learn about these NumPy? So there is something else that we should maybe learn here. We are saying that iterating arrays with different data types. So you notice that we have been using what? We have been using arrays with just numerical values. So and we are saying that we can use the op underscore d types argument and pass it the expected data types to change the data type of element while iterating. So we are saying that NumPy does not change the data type of the element in place. So it needs some other space to perform this action, and that action is now performed using the op underscore the d types. So let's see how we can implement that. I think we have an example here. Let's go through this example together. And we are saying that iterate through an array as a string. So, and the first thing that we are going to do is always to import the number as np, and then we have our array here. That is array is equals to np np dot array function. Then we pass in our values, and then let's say now we want to loop through this as a string. Because at the moment these numbers, these are numerical values, right? But now we can loop through these as strings, and that is why we are bringing in two parameters here. That is the frags parameter, and we always pass the buffered, and the op, we call it the op underscore d type, and then we are passing these s. The s here is to mean that you want to loop through this as a string. It's just that easy. You just have to use you just have to add the two the two parameters, that is the frags parameter and the op underscore d type, and then you should be able now to loop through this as a as a string. So I think that is it with iterating an array with different data types. I don't know if this one is relevant at this case, but we can use have a filtered iteration, and with this I think we learned how you can slice. I think we learned how you can slice elements in an array. So again, that is how we are saying that we can filter using you can have a filtered iteration. Let's say maybe loop through you want to loop through a number of items in your array. You can do that using again you can achieve that using the nd iter, whereby you're just passing the let me just show you this. I think it's good I demonstrate this. Let me just copy this and run through this. It's just easy. We also going like to cover the slicing in NumPy, but is similar to what we covered last. So the first step we import NumPy as NP, and then we have our array in place, and then now in this case we want to have this filtered iteration. So we just have to, if we run these, you notice instead of having all these elements, we are just having the first the first element here, that is 1, and then we have 3, and then we have 5, and then we have 7, right? Because now in here we are just saying that we just want the first, by just putting this colon, it's just telling these that we just want to. Okay, let me show you that. I think we should learn slicing. I believe it's covered here, or it is in the next slide. Yes, I think we should check these slicing, because I think I'll introduce something we call step. I think it's just right here. Let me just check these. Let me see this. I think you're going just to check it, but let's go through this example. So in this case here, the reason why we are getting 1, and then we jump 2, and then we get what we get now. We get 1, we jump 2, we get 3, we jump 4, we get 5, we jump 6, we get 7. It's because we introduce something we call we're just calling a step. So meaning that we want to have a step of 2, that is from the initial or from the first element. So meaning that we just want to have a one jump here. So that is from 1, we jump the second item, and then we are going to like to be jumping one item. Anytime we print 1, we jump the next. And that is why we are getting this kind of a pattern here. Getting a 1, we jump to 3, get 5, then we get 7, and then you notice that we are not getting an 8. But you're going to see we are going to see this kind of a slicing. I think it's somewhere in lecture number 7. I think I shouldn't have given that example before taking you through that, but we are going to see that. But just know that you can have a filtered iteration through now the slicing. So let's see the enumerated iteration using the ND enumerate. And I was saying that enumeration means mentioning sequence numbers of something one by one. We say that sometimes we require corresponding index of the elements while iterating. So meaning that you want also to indicate the number of index of your elements. And for us not to print out that, we use this function that is called nd enumerate. So I think we can have an example. I think example will with an example you're going to understand this better. Let me just try to use this example here. Let me share these. So with this we're able also to print the indexes of our elements. You notice that with the last iteration we were not printing the indexes of our elements, but now with these, whereby we have for ID, in fact this one are just this one is just a variable that is going to represent our index. And now these x will represent our value or our element. In fact, if I was just to remove this, let me just try to remove this, and I just run through this. Let me just oops. Let me see this 1, 2, 3 print. I think it's because I'm using. Let me just try to. Let me have, instead of this, let me just have the nd item. Let me just try to print this. You notice that with nd item, we are not able to print the indexes of these elements. But now with when you use the nd enumerate here, that is got it, the nd is this. You can just undo this. The nd enumerate, we are going now to print we are going to like this nd enumerate is going to help us to print the indexes of these elements. Like 1 is at index 0, 2 is at index 1, and 3 is at index 2. So if you want now to print these, we bring in the nd enumerate, and we are going to have ndx as our index, and then x as our element, and then we are going to print the ndx. This one will represent our index, and then the value here, which is now x. You just happen to run through this. You notice that now you're able to get the indexes of our elements here. And now this one applies even to this one is a 1 dimensional array. So this one is going to apply to even two dimensional arrays and three dimensional arrays. So you can also try that on your machine. So, but that is how we use the nd enumerate to get the indexes of our elements while doing the iteration. So these are some of the methods. But then these are some of the methods that we are going to that you are going to use during the analysis. So you might be required to do an nd enumerate in your data set. So yeah, so it's always good to learn these. So, and that's all with nd enumerate. I don't know if there is any question on that before we go to something we call what we call joining of arrays. I don't know if there is any question before we move to joining of arrays. Any question? Thumbs up if you are together up to that point. Yes, I can see you're good. Caroline, are we together? Yeah, so let's move to the next part of our discussion, whereby you might maybe be required to join arrays. Might be required to join arrays. So, and in Python, joining arrays just means that you're just trying to bring two arrays together, or joining two, or bringing two arrays together to form one, to form a single array. And in arrays, we have something called concatenate function that will help us to that will help us to that will help us to join two arrays. But for you to join two arrays to get to form a single array, those arrays they must have same elements. So that is the condition. You cannot join an array with 4 elements. You try to join it with an array with 3 elements. So that one won't work. That one will give you an error. So for you to join two arrays, they must have same number of elements. So I think that is it. And I think we can just start with simple arrays, whereby we have an array 1 with numbers 1, 2, 3, and the array 2 where an array 2 has 4, 5, 6. So we can join these two arrays to form one arrays using the concatenate method. So it's just that simple. So it's np, we import numpy as np, and then we have let me just try to run these so that we can see it in action. So it's an easy thing. So first we import the numpy, that is the first step, and then you define your two arrays. I think by now you know how to create an ND array. That is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So and then the array 2. To concatenate these or to join these, I think you can just call this joined underscore array. So if we try to print this, the joint array here, I think we should be able to get an array, a single array with all these elements. Let's see. And now you can see that we have a single array with all these elements. But maybe if we happen to add something, let's see. Let's add an array, another element here. Let's try to add these. Oops. Let's try to add these. Let's have that. I think you can just have these. Okay, I think it's just appropriate with a comma here. So you notice if we just happen to run these, you notice that we don't have problem with these one-dimensional arrays here. This one is a one-dimensional, right? This one is a 1D 1D array. And also even this one is a 1D array here. So, but you notice that this one has 3 elements and that this one has four elements. But if even we try to run these, you notice that it is still concatenating, or it's still joining them into one single array. But now from two-dimensional array, we are going to encounter some issues. You are going to encounter some issues, because for you to concatenate a two-dimensional array or a three-dimensional array, then it means they must have the same number of elements, and we are going to see that. We are going to see that in a while. So that is how we join one-dimensional arrays. And I don't know if there is any question on that. I don't know if there is any question. So this one is a two-dimensional array. Let's have this example and see what happens. Let's have this example here and see what happens. I think I can highlight all of these and then comment. So we have this one is a 2D array. I think it's good to indicate that 2D array, and also this one is a 2D array. I think you can just copy paste that here. But now you notice here that the first and the second 2D arrays, they have the same number of elements. So this one will concatenate well, or this one will join into one array that is along the axis. In fact, we are joining them along the y-axis. If you just happen to run through these, I think you can see that we are able to combine these. That is the 1, 2, 5, 6. Then we have 3, 4, and 7, 8. So this is what we are calling concatenating along the x-axis or along the rows. But if we happen, maybe let's say happen to add another value here, and maybe let's try to combine these. You notice that now we are getting an error here, and the error that you are getting here is telling us that the requested array has an inhomogeneous shape after one dimension. So meaning that for us to connect to join these 2D arrays, then they must be homogeneous, or what we are referring to as having the same elements. You notice that this one is a 2D array, but this one is having 2 elements, and the second one here is having the element number 2 is having three elements. So now it becomes a problem to join with a 2D array with 2D with I mean 2 elements in each element here. And that is why we are getting this error. So you should be careful while joining, when trying to join these arrays. In fact, these arrays these are just hard-coded values. And now the reason why I'm teaching these, maybe some of you are just trying to think, okay, where am I going to apply these? Let's say maybe, I'm just using hard-coded values, but this one can be applied in cases where you want to combine data sets. Yeah. So that is one application where you can be required to join a number of data sets. And now for you to successfully join data sets, then it means that you have to check a number of things, right? So I think that is it. Any question? Thumbs up if you're together. Yeah, I can see most of us we are together. So I think that is it with the of joining of arrays. But I think this is something that you can try and do what you can just try. I'll share with you a link. That is a link on what? That is a link on the documentation of NumPy, so that uh, you can just have an extensive reading on how you can join arrays. Yeah, I think that is it. I don't think I have to mention anything else. Let me see. Maybe something that I can mention here before we call off this meeting is if at all now you can join two arrays, it means also you can divide the arrays, and that is what we call now splitting in arrays, right? So you can like the splitting is the reverse of the operation of joining. So meaning that yeah, you can maybe try to divide your data set into multiple data sets. And that is why we have a function that again help us to do that. That is array underscore split. This is a function that will help you to split your data set into two, or into multiple splits. So maybe I can just demonstrate that how it's used. Let me just try to cut that and paste it here, explain what is happening. So this is the array that we have. That is an array, one dimensional, a 1D array. Is a 1D array. Let me just hash 1D array, a 1D array. So then we can split these. We can split these. And how we do it, how we do this is you just have like to have the variable here, the new arrays. You can just call them the new arrays here. And now what you're going to do is pass in your array in these. In fact, these function accepts two parameters. And the two parameters, the first parameter is the array that you want to subdivide. And then the second parameter, or the second param, is the number of times that you want to divide that. The number of times that you want to divide that. The number of times that you want to divide that array. If I just happen to run through these, you can see that I'm having array 1 with just 1, 2. We have the second array with 3, 4, and then we have array what? Array 3 with 5, 5, 6. If I just happen, maybe let's say I want to divide this one into 2, I just have to. I'll now have 3 elements in each array. You can see I have the first one here and the second one here. So what if you put maybe an odd number here? Let's see. You can see that now I have the first element having two items, and the rest having each one item. But you notice that now I have 5 arrays in this. So you can divide. In short, you can divide an array into a number of arrays. So any question on that? Do you have question? I don't think there is something else to cover on this. But on the documentation, you are going to see these. You are going to see these. You're going to see these. You're going to see these functions. We have the H split, which is an opposite of H stack. I think from the documentation, you should be able to see how we use how we use these functions of like the H split, the H stack. You just see how the is. I'll share with you um, I'll share with you a link. I'll share with you a link so that you can at least check these on your own. So the next thing that I should cover last is sorting of arrays. And sorting means just putting elements in the order of order sequence, right? And I don't think there is much to cover on this course. We have a function that is called sort, and now this one will just sort your array. So I think I can just give you an example here where I have an import. Let me just copy that and use it somewhere here. So let's see this. Um, if I just happen to run this, you notice that I have just sorted by use of this sort function. I'm able to sort my array here. That is in ascending order. Um, that is 0, 0, 1, 2, 2, 3. In fact, I had just let's try to add some elements here and see if you're able to sort that. And then you can see that we're able to sort that very fast by just use of this function. So it's np from the numpy, then dot sort, and then we just pass our array, and then our array is sorted. So in fact, these functions, they are very simple, but you should at least learn how they are applied, so that now when it comes to analysis, it will be easier for you to manipulate your data. Um, so let's see. I think that's all. I don't have to talk much about sorting. Um, yeah, I think that is it. So tomorrow we are going to start on a new library that is called matplotlib. And with matplotlib, we are going to see how we do now visualization. I know most of us have been maybe wondering, have you done any analysis? Have you done any visualization? So after learning this matplotlib function library in Python, we are going to do a full project that will involve uh, or that will that is going to demand you to apply all these skills. That is from reading the data set, cleaning the data set, trying to manipulate the fields that you have, and doing now the visualization now of the analysis that we are going to do. So tomorrow we are going to start on something called matplotlib. This is another library that is used in now visualization. We are going to see a number of visuals that we use in Python to to visualize our analysis. So, any question before we call off this meeting? Do we have any question? Lynette, any question? I think some of us have never talked in this meeting. Lynette, any question? If no question, you can